Welcome to today's Explainer. We're diving straight into the invisible data infrastructure that is literally powering our modern world. We are moving far, far beyond your basic static maps. Today, we're dissecting the core engines of geospatial technology, the tools that drive the real-time, three-dimensional digital twins of the Earth.
So what exactly are geospatial technologies? Basically, they're technologies that deal with data that has a geographic or spatial component. But the shift we're looking at isn't just about data tied to a specific location on a map. It's a massive structural leap, from physical constraints to real-time dynamic modeling. We're taking raw geographic components and translating them into actionable, multidimensional intelligence at speeds and scales that were completely unimaginable just a few years ago.
Here's our roadmap for today. We'll start with the geospatial data revolution, then dive into GIS, the master map, remote sensing, eyes above, GPS, pinpointing our world, and finally wrap up with our geospatial future.
Part 1. The Geospatial Data Revolution, Transforming Spatial Data.
Moving into Part 2, GIS, the master map, the organizer, and analyzer.
You can really think of GIS, or Geographic Information Systems, as the brain of this whole geospatial operation. The true power here isn't just running a single piece of software. It's a highly robust lifecycle that turns raw, unstructured data into actionable intelligence. It's a 5-step process. We capture the inputs, securely store them, manipulate the data to ensure clean usability, and then hit the analyze phase. And that's where the heavy lifting happens, right? Running those complex queries and algorithms before finally displaying the geographically referenced output.
At its core, GIS goes way beyond just drawing digital maps. It functions as advanced relational database management, connecting non-spatial data directly to spatial geometries. And that gives us a few key features. First, spatial analysis, which lets us build proximity, overlay, and network models. Next is data visualization, using maps, charts, and graphs to instantly clarify massive data sets. And all of this is supported by top-tier data management, which efficiently stores and processes enormous volumes of spatial information.
This infrastructure is the backbone of macro-level problem-solving across the globe. We're using these GIS applications every single day, for urban planning to design highly efficient smart cities, natural resource management to safeguard complex ecosystems, rapid response disaster management during catastrophic weather events, and precision agriculture to maximize crop yields through intricate soil and terrain analysis.
But wait, all of this macro-level analysis requires immense data inputs. So, how do we gather precise spatial information when sending field surveyors into hazardous or politically inaccessible regions simply isn't an option? How do we map what we can't touch?
That brings us to Part 3, Remote Sensing, Eyes Above, Gathering Data Without Physical Contact.
By utilizing advanced sensors mounted on aircraft, satellites, and drones, remote sensing gives us two distinct operational advantages: wide area coverage versus multispectral data. First, wide area coverage allows us to gather data over massive remote terrains quickly and cost-effectively. Second, it captures multispectral data. Instead of just snapping standard photography, these sensors read across various spectrums, including infrared and microwave. This gives us a deeply layered, comprehensive view of the Earth's surface that goes way beyond what the human eye can see.
Because these sensors are maintaining continuous observation, they unlock a critical capability: change detection. Literally detecting changes in the Earth's surface over time. This isn't just about watching the Earth change visually, it's about generating quantifiable historical metadata. That data is absolutely vital for predictive climate modeling, tracking rapid land use shifts like deforestation, and assessing the immediate, measurable aftermath of natural disasters.
Okay, so we've got the broad, high-level environmental observation covered, but what happens when we need to bring it down to the personal level? What happens when we need to pinpoint our exact location on that surface? Part 4. GPS, Pinpointing Our World. Satellite-based navigation system.
The Global Positioning System provides highly precise location and time information anywhere on the planet, and the true power of GPS lies in its dual nature. Take a look at these everyday GPS applications compared to essential industries. It powers things like basic navigation and surveying, mapping, and geocaching. But simultaneously, it serves as the critical backbone for essential industries. We rely on it completely for complex transportation networks, global logistics chains, and emergency services where having exact location data literally saves lives.
Serving both weekend recreational users and massive global supply chains requires two specific capabilities: accurate positioning and real-time tracking. Accurate positioning provides the highly precise static coordinates you need for detailed land surveying and mapping. Meanwhile, real-time tracking gives you the dynamic capability to monitor objects continuously as they move globally, which forms the operational core of modern logistics.
You know, the ultimate triumph of GPS is honestly its frictionless usability. It is incredibly easy to use with no specialized training required. An insanely complex, space-based satellite constellation is seamlessly integrated into our daily lives. You literally just open an application on your phone and instantly connect to a multi-billion-dollar piece of orbital infrastructure. It's kind of wild when you think about it.
And finally, Part 5, our geospatial future, a constantly evolving landscape. When we bring together geographic information systems, remote sensing, and GPS, we have the three pillars that absolutely revolutionize spatial data processing across government, enterprise, and research. But this is really just the foundation. As these technologies integrate further, the future isn't just about creating better maps. It's about powering autonomous systems, deep AI integration, and predictive spatial intelligence that anticipates changes before they even happen. So as these technologies constantly evolve and improve, what innovative spatial applications will we uncover next? The architecture of our world is rewriting itself in real time. Thanks so much for joining me on this explainer.